Okay, another day, another video. A few months back, I did a video on GraphQL and iOS, specifically on how to set up Apollo GraphQL client on iOS and do basic querying. So this time I want to take that video a little further and have a much more complicated schema and querying. So as you can see here on the left-hand side, this is a node application. It's using Apollo GraphQL. And in the case of this schema, I am having multiple interfaces and a union type. Now, if you're not familiar with interfaces, basically they're a lot like protocols in Swift. So it's a contract, you have some member fields, and then anything that implements the interface has to implement the fields. And in this case, iPassenger vehicle adds its own field as well. And then after that, these interfaces can be implemented by an actual type. And if whatever it implements, it needs to define all of the fields. So this hierarchy I thought was pretty simple to understand, the base vehicle type and then various inheritors of that type that more and more have their own fields. So then the hard types that we're going to have is car, truck, and boat. And then we're going to be returning all of these types in an array. And the way to do that is by using a union. A union is just a way to have a single type that could represent one of several types. So in this line, it does not mean that search result is all three of these types at the same time. It just means that it's either car or truck or boat. So we're going to have this simple query in our sample GraphQL server. Like I said, it's going to return an array of this search result union. If you take a look at the resolvers, another thing that you want to make sure that you have when you are using interfaces and unions is you need to have a translator that takes the union or the interface and via your own logic returns the appropriate type, the appropriate hard type. And that is because the queries can never return the interface or the union. Ultimately, they have to return the hard type because the hard types are the only things that have the implementations and the field values. So in this case, my logic is to look for certain member fields, and then depending on what they are, I request a certain particular type. This is based off of the object that is coming in, meaning the real JavaScript object that was returned by your data store, and the members that it possesses. But in here, I just want to make clear that the logic is totally up to you. It doesn't have to be, this. It doesn't even have to be member-based if you don't want it to be. But obviously, doing something with the members makes a lot of sense. So the base interface, iVehicle, it's basically the same thing. iPassenger vehicle only returns cars or boats because those are the only things for passenger vehicle. Those are the only types for passenger vehicle. In the case of iWork vehicle, no matter what the fields are, it's only ever going to return a truck. And this is pretty obvious as well. So this is TypeScript. I just want to make that clear. So the unions in GraphQL and the unions in TypeScript are basically identical. Again, it's or. It's either car or truck or boat, and it's in an array. So these data are just random. They're cars, boats, trucks, whatever, and they're all mixed in this single returned array. So it's going to be our job on the iOS client side to parse through that data set to figure out which specific type that the returned object is, and then to cast it to that type so we can access the appropriate members. So just be aware that since we're using TypeScript, I created these TypeScript types that represent the schema. And let's take a look at the result. So if you look down here, my URL is http localhost 8000. So before I run the query, let me just explain it. So if you look at this, you'll see type name. This just means the name of the type. So if a car returns, the name of the type will be car, and truck and boat. Every possible type that could be returned might have varying type members. So this line right here represents an inline fragment. That just means that you're defining the member fields that you want to see if the type happens to be a car, and the same thing for a truck, and the same thing for a boat. So if I run this query, you can see that the ID and name come back, the wheel count, and the passenger count. But in the case of boat, there is no passenger count, so we don't request it. But there is no wheel count, so we don't request it. But if we did, let's say by accident, we would get an error because that field doesn't actually exist. And if I tried to run it, we would get a validation error on the boat because wheel count doesn't exist. So again, this is going to tell us, depending on which type it is, what specific fields we want. In the case of truck, it does have wheel count and it has max payload, and therefore that's what we get. So we are going to attempt to run this query on our iOS client. And since iOS SwiftUI is statically typed, we will have to do some extra work in order to extract those typing informations. So if we go to our client, just so you know, I've already installed Apollo Client. If you're not familiar with how to install and configure Apollo Client, it's actually pretty involved. So I'll leave a link to my prior video that shows how to do that. But basically, I've set it all up. It does compile. Just be aware, or as a refresher, you need the schema file that represents the type schema, the type defs of your GraphQL server. And you need to define a specific query or queries that you want to run. This single file could have multiple queries and mutations in it, or you could have one file per query or mutation, whatever you want to do. As you can see, this query is identical to the one we tested on the browser. I've also gone ahead and created the GraphQL client, which is what attaches to our server. As you can see, it's the same URL as our test server. And I've also gone ahead, just like on the TypeScript side, I've gone ahead and created the view model classes and protocols Again, interfaces in TypeScript and GraphQL are a lot like protocols in Swift. And then I've created these types with constructors for convenience. And part of the reason also why I did this is whenever you're getting data from some network service, whether it's GraphQL or not, obviously you're not just going to take the data as is and dump it into your view. You're going to massage the data, convert it into a format that your view understands, and then feed it to the view. So that's part of the reason why I did this, although there's really no difference in this example case. And then the other thing that I need to mention is obviously you're going from type defs that are just strings, right? This is the string interpolator in JavaScript, right? So you're going basically from no types to static types. So part of the job of the Apollo client is to take the schema information, your query, and convert that or code gen that into an actual set of static types for your Swift app to use. So in this case, I only have a single query that I've defined. So this is the only root type that we're going to see. If I had another query like get cars or something like that, then we would see another one of these root classes called get cars query or get cars mutation if it was a mutation. And then inside of here, on top of having the query, you're going to see the data type, which is what we always get in every return GraphQL query. And then you're going to see the name of the actual query itself. But in the case of SwiftUI, it's going to return a type. And this type name is getAllVehicle, and our query returns an array. So inside of this getAllVehicle, you're going to see this as car, as truck, as boat. And this is because we are using unions. So it needs to be able to take this bunch of data, these objects coming in that could be of any type, and allow you to cast them to the appropriate type that they are. So these as car calls or as truck or as boat will allow us to do that. And as part of that typing info, we're going to again get the type name, and we're going to get the ID, the name field, the passenger count in case of the boat and the car, and the wheel count in case of cars and trucks. So we see as truck here as well, and there's also as boat. So again, this is code gen by Apollo GraphQL. And let's get started. So I'm going to create an observable object. And this observable object is going to have an array of cars. It's going to have an array of trucks. And of course, an array of boats. And the way we're going to get these is we're going to, again, use those casting properties to try and cast them, each object as it comes in. And then if it is successful, then we'll populate the appropriate array. So what we're going to do is we're going to use that GQL client. We're going to do a fetch call. And that fetch call is going to use that root type. and then we'll get the result set that comes from that. And in the case of a failure, I'll just print out the failure. In the case of a success, get that success, and I'll attempt my cast. So again, starts at data, then you have the real name of the query itself. So if this vehicle is a car, then I'm going to create a car instance, and I'm going to populate it into my cars array. Just be aware, some of these fields as they come back, they're going to be optionals. So you want to check for that. Let's just make things a little easier. Truck does not have All right, so this compiles. So once again, if any of these arrays get updated, it will update our view. This is getting the data. When it gets the data, it tries to figure out, hey, are you a car? Are you a truck? Are you a boat? And then depending on what it is, it'll insert it into the appropriate array. And then in our view, I'm just going to keep things simple. I'm going to just use a bunch of text to display these vehicles. So the first one is going to be cars. Oh, I hate this keyboard. I've set these to be identifiable just to make things easier for each loops. So here we're just going to get some of the fields that are in the vehicle. So we'll do that for each one or each type. So this is going to be for trucks. All right. So if we bring up our run here, name car 1 has a wheel count of 4 and a passenger count of 5. The first truck 1 has a wheel count of 4 and a max payload of 5,000. This is the first truck right here. And then the boat 1 has a passenger count of 2 because it does not have wheel counts. Okay, so that is working. So now I want to show you a few more things. So if we go back to our query, we can see that I am repeating these guys multiple times. So what we could do is we could make use of our interface and instead of repeating these over and over again, we could just reuse the fragment that I have defined here. So these are inline fragments, and this is a fragment definition. So then if I do it this way, I get code reuse, but I also prevent issues with typos and stuff like that. In the case of 2 fields, obviously it's not a big deal, but there's plenty of business objects models out there that have 30, 40, 50 fields in them. And in some cases, it's possible that your query might use most or all of those fields. You don't want to be repeating that 3, 4, 5 times, right? Depending on how many types you have. So if you use this fragment, you can define it once and just reuse it wherever you need to. So then if we run this query, let me just show you after a page refresh. Okay, so if we run this query, we see ID, name, wheel count, ID, name. So everything does come back. Now, if we try to use this in SwiftUI, it actually gives an error. And let me have it apples to apples. I'll put a query name in here, just like how I had it before. So if I try to build this, it fails because fragments are not supported. So what is the way around this issue? In the case of this query, I don't care whether I use a fragment or not. All I'm trying to do is not have to, I'm trying to eliminate this redundancy, right? So what I could do instead is, since all of these types inherit from iVehicle, the interface, I could simply get rid of that fragment, get rid of these, and just add this inline fragment. The reason why this works is each of these have an iVehicle inside of them, right? So if I refresh the screen, this should still work, and it does. You see the ID and name, but it's in the bottom because the definition of the interface is on the bottom. So if I take this, get rid of this, so the build succeeded this time. And then it works. Now, just to kind of prove that it really, really works, I'm not going to do it for the other ones. Just do it for cars. So as you can see, the ID does come in. Now, just be aware, the reason why I had to do this is because inside of here, if you don't have a name for your query or mutation, the build will fail. And I believe the reason for that is so that it can create that base type. So it needs some kind of name for the query. So that's definitely one thing to be aware of as you're building these out. The other thing to be aware of for testing purposes is that by default, SwiftUI, or that is iOS apps, do not allow non-secured domain names. So in other words, they only accept HTTPS URLs, which obviously our local test server is not. It's just HTTP. So what I had to do is I had to add this attribute key right here, app transport security settings. Now it's a lot more than that, which is why I'm showing you the XML. And basically it's this XML right here. The most important of which being the domain that you're trying to interact with. And notice I have the port number because even if it's localhost on a different port, it will not work. So you need to reference the port number. And then the big one is this guy, allow insecure HTTP loads, which enables regular non-SSL HTTP domains. So for testing purposes, that's the other item that you want to be aware of. So that's it. If this video was useful to you, definitely hit the like button. If you end up having some problems, some questions, put your questions on dzhaven.com and I will answer them there.